A city stands on solid ground. In Chongqing, China, engineers looked at a mountain and saw something else entirely. They saw the floor of the world's largest train station. Not beside the mountain, not around it, on top of it. Today, a structure covering more than 1 million square meters rises from solid rock, larger than 2 Vatican cities combined. 15 platforms, 29 railway lines, 8 levels stacked above a slope that engineers once called impossible to build on. It took just 38 months to finish, 14,000 workers, billions of dollars, and an army of construction robots. But before any of that could happen, engineers first had to solve a problem nobody had solved at this scale before. How do you build the world's biggest railway station on ground that refuses to stay flat, on a mountainside no one thought could hold it? This is the story of how China turned a mountain into a monument to modern engineering. Chongqing is unlike any other city in China. Locals call it the Mountain City, the River City, even Cyberpunk City. Built across steep ridges and river valleys, the city is famously three-dimensional. Roads climb, dive, and vanish into buildings. One train line already cuts straight through the middle of an apartment block because flat ground was simply too rare to waste. Another station sits 116 meters underground, the deepest in the world, buried beneath layers of solid rock. For decades, this terrain made Chongqing a nightmare for large infrastructure. Mountains blocked roads, rivers split neighborhoods apart. Yet Chongqing was growing fast. Its population had quadrupled in 30 years, reaching 10 million people and still rising. More than 3 billion train journeys crossed China's rail network in a single year, and Chongqing needed to keep pace. The city needed a station that could connect it to 14 major cities, carrying high-speed trains longer than 4 football pitches. But there was almost nowhere left to build one. Every stretch of flat land in the city was already taken, except for one place, a mountain 20 kilometers from downtown, standing directly in the way of everything. Normally, engineers avoid building major stations on mountains. Slopes complicate foundations, drainage, and long, heavy platforms. Flattening the mountain completely would have taken years, and even then, the ground beneath might never sit fully still. Building around the mountain would waste the very land the growing city needed most. Neither option solved the real problem. So instead of avoiding the mountain, China's engineers decided to build directly onto it, treating the slope as the foundation itself. The plan called for cutting and blasting sections of rock, then leveling the terrain into a stable base for construction. Deep piles would be drilled into the mountain to anchor the structure, transferring its enormous weight straight into solid stone.
5 concrete tiers.
Engineers designed the station to rise in stages. 5 lower levels first, then 3 upper levels stacked above them. Every frame would be built from reinforced concrete, strong enough to carry platforms stretching more than 400 meters long. The roof presented its own challenge. It needed to span the entire structure without a single load-bearing column beneath it. The solution borrowed from nature itself. Branching columns shaped like the Huangjue tree, Chongqing's official city tree. Deep foundation piles were drilled into the mountain, some reaching far below the surface to lock onto stable bedrock. With the base secured, workers began pouring nearly 2 million cubic meters of concrete into the rising structure. More than 360,000 tons of steel reinforced the frame, more than double the amount used in some of America's largest dams. Temperatures on site regularly climbed past 40 degrees Celsius, threatening to crack the concrete before it could properly set. Engineers ran networks of cooling pipes through the wet concrete, pulling the heat away before cracks could ever form. To keep pace in the heat, construction crews turned to an unusual workforce, an army of construction robots. Laser-guided robots swept across the site, leveling ground with a precision no human crew could match by hand alone. Four-wheeled screed machines, guided by satellite positioning, smoothed vast concrete platforms one accurate pass at a time. Tile-laying robots moved methodically across finished floors, setting patterns with a consistency that saved weeks of manual labor. Perhaps strangest of all were the sentinel robots, using AI vision to spot missing hard hats or misplaced vehicles on site. Reports suggest these machines tripled construction efficiency, cut labor costs in half, and reduced safety incidents by 90%. With the base structure rising, attention turned to the station's single most difficult feature, its enormous roof. The roof alone would weigh 16,500 tons, spanning an area of 120,000 square meters. Rather than assemble it high in the air, engineers built the entire steel tube truss roof on the ground first. Then, using hydraulic jacks, they lifted the massive structure 57 meters upward, sliding it slowly into its final position. Giant branching columns, modeled after the Huangjue tree and standing 41 meters tall, rose to catch the roof's full weight. The branching design wasn't just decorative. It was engineered to flex and absorb force during a major earthquake. Once the roof settled into place, robots hoisted glass panels weighing 800 kilograms each into the towering facade. Welding robots followed behind, fusing steel joints together with a precision built for endless repetition, not fatigue. After months of relentless work, the mountain had vanished beneath a station larger than most cities' entire downtowns. Today, Chongqing East operates as far more than a train station. It functions like a small, self-contained city. High-speed trains reaching 350 kilometers per hour glide onto platforms built to handle 16,000 passengers an hour. Beneath the high-speed lines, conventional trains, metro cars, buses, and taxis all converge under the very same sweeping roof. Passengers traveling to Chongqing's main airport can check in for their flight and even drop off luggage before boarding a train. The station links Chongqing directly to 14 major cities, threading the mountainous southwest into China's high-speed rail network. But a station this size, built in this location, inevitably faces extreme conditions, and engineers built it to withstand them. Those branching tree-shaped columns supporting the roof are designed specifically to flex and absorb energy during seismic activity. The reinforced concrete frame, anchored deep into the mountain's bedrock, was engineered to resist the shifting ground beneath it. Even through Chongqing's punishing summer heat, the station's cooling systems and structural design keep operations running smoothly year-round. Every system, from drainage to structural flexing, had to work in concert with a mountain that never truly stopped shifting. When Chongqing East opened, it claimed the title of the largest railway station on Earth, 6 times the size of Grand Central. For Chongqing, a city of 10 million people, the station became a symbol of a region finally catching up. It anchors China's wider ambition, a high-speed rail network already stretching more than 50,000 kilometers across the country. The project also became a testing ground for construction robotics, proving that machines could reshape how megaprojects get built. Whether this pace of building can continue forever remains an open question, one even China's own engineers are asking. But for now, a mountain that once stood in the way has become the foundation for something extraordinary. Chongqing East stands as proof that when a mountain blocks the way forward, engineers can simply build on top of it.